of the range. Okay, cool. This is what our textbook tells us. What in the world does that mean? Each element of the
domain
x, each x is paired with exactly one y. So if one x can only be paired with one y, what would be a situation where that doesn't happen? So here's some x values. Are those x's all paired with one y?
Yeah.
Yes. What would be a situation where each x isn't paired with just one y?
When there's a double and a y.
If I did that, now how many times is this 3 being used?
Twice.
Twice. So this is a really fancy way of saying the x value can't repeat. Can't use it twice. Can't get paired up with something that if it's already partnered with something. Okay, so we want to decide by looking at these examples below whether or not we are talking about a function. Okay, so every example we look at, is it going to be a relation?
Yeah.
Yes, why?
Because
They're all relations. It's all relations. So we want to decide if it's a specific type of relation that we call a function. Okay, so if we look at A up here, how might we decide if it is a function or not? Look at the x values. So we want to look at the x values. And what do we want to decide about the x values? Are there any repeats? So does the x value repeat? No. So is this a function? Yes. It's a backwards question. That's annoying, but it is. Does the x value repeat? No. So is this a function? Yes. Yes, this is a function.
Wait, can you say that again? If it doesn't repeat, it's a function? Or if it
Correct.
does? Okay.
So the question we're sort of asking ourselves is, does the x value repeat? In this case, no. So is it a function?
Yes.
Yes. Backwards. Weird. B. Is this a function?
Yes.
No.
No. Yes.
-1 repeat.
No, it is actually a function.
Okay, so the question is, does the x
Yeah.
value repeat? Now,
Yeah, -1 repeats.
would we see this value written twice in a mapping?
B, it's the two
No, we're looking at B.
it's not a function because -1
Well,
and
look at
-2
C.
are both.
No, don't worry about C.
We're
Look at B.
doing
Oh.
Yeah.
No, it is a function. It's a
Okay.
function.
Okay, so pause. So now we're all looking at B, and we're looking here, right? So we're looking at the x values right here. In a mapping, should we see a number written down twice?
No.
No, because the rule said no repeats. So how are we going to decide if it is used twice? Logan?
If one number goes to, or two numbers go to one.
Right, so if two, no.
No, if one number goes to 2.
If one x goes to two
Two
y's.
y's.
So this would have 2 lines coming from it. Does the y value matter at all when we're determining this?
No.
No, so this stuff over here doesn't count, doesn't matter. So we're only looking at the x's. So how many lines does this have? One, so is it a function?
Yes.
One line?
One.
One line, one line, so
Yeah.
does this count as a function?
Yes.
Yep, because does the x value repeat? No. What happens if I drew a line here?
Then it is not.
Whoa.
Because it was used twice, right?
Whoa.
So this is a function.
Trippy.
How about C?
No.
No.
Why not?
-1 repeats.
Is this a relation?
Yes.
Yes. How often is a function a relation?
Always.
Always. How often is a relation a function?
Never.
Not always.
Not once.
Not always, sometimes.
Yeah.
Right? A function is always a relation. A relation is sometimes a function. Graphs are a little bit trickier. Because are we going to see an actual repeat happen in a graph? I mean, not in terms
Unless you go
of
in a
just
circle.
seeing a number written twice.
If it goes in the circle.
Okay, so to see if a graph is a function or not, we use something called a vertical line test. It's super creatively named. We can thank Old Dead Men for that as well. A vertical line test says draw a vertical line and see if it touches the graph more than once. Okay, so you can't just imagine a single vertical line. So I kind of like tell students, like, maybe set your pencil down or the edge of your folder or something and imagine vertical lines across this graph.
There are vertical lines on the graph.
I mean, there are those there, but you have to imagine like infinitely many of them going across. Do we see a vertical line that touches this graph more than once?
Yes.
Yes, like multiples of them. It doesn't matter if you can find one or if you can find a million. If you can find a line that touches it more than once, it's not a function. Okay, so this is not a function. Why? Why?
It
Does-
isn't.
There'd be two X's.
Because the old dead man said so.
What is this ordered pair?
0, 4.
I'm over one, so. Okay, it's okay, we can go with this ordered pair here. So this is the ordered pair 0, 4. And what is this ordered pair then down here?
0,
0, -4. Was that x value repeated?
Yes.
Right, so along those vertical lines, we have the same x value. So that one's not a function.
Wait, so would so B would be a function, right?
Right, because now vertical line is anywhere, is it touching twice? Once,
No.
once, so this is a function.
Does that make C a function?
I'm trying to find a way to break C.
It's a
I feel
function.
like at an angle.
Yes.
Well, don't write it at an angle then.
Once. Is there anywhere it's gonna be twice? Nope, so is this a function?
Yes.
If you write it on its side.
Well, if it were to go on its side, then we start getting into like hyperbolas and conics of other types, and those would not be functions. We are not ready for that.
Okay.
Come on, Cade. Cade.
Last new piece of today, which will also be points on your test, is that you know what an inverse is.
Ooh.
An inverse says that you can invert an x and y value. So if you are given an ordered pair A comma B, the inverse of it is B comma A. So if we were given the ordered pair 1 comma 2, the inverse of it would be
2, 1.
2 comma 1, 3 comma 0, 5 comma 2. I mean, it just requires you knowing what an inverse is. It requires no really math ability.